Okay, hello everyone. So in this video we want to go over example 12.6. Now you'll notice that it's a little bit different from the book. It's a little out of order. So you have the information about the line of best fit first, and then we look at this afterwards. So what I want to do today is I want to show you how to do a scatter plot in Excel, and then compute line of best fit. So let's get started. So first thing I'm going to need to do is get this data. And so, as usual, I'm going to try my best to take a screenshot here. All right, looks like the data was copied. Let's copy it. Now let's go to Excel. Scroll down here to let's actually go to a new. Let's close, save. All right, let's create a new. There we go. And let's paste. Allow. All right, and there's my data, along with a bit of other information that I would like to delete for now. Let's go ahead. Okay. All right, so here's my data, and what I would like to do is make a scatter plot of this in Excel. There we go. Okay, let me just do a little bit of formatting here. Let's get rid of the text wrap. That's there. All right, so first thing I'm going to do is I'm going to select my X and Y, and then I'm going to go to Insert, and I look at Charts over there, and I go to Scatter Plot, and I just want the one, there we go. All right, so the Y-axis here are the final exam scores, and the X-axis is the third exam. Now our options in for these plots in the iPad version are limited, so I'm not even going to mess with it. But as you can see, I would say that there is a fairly strong correlation here. If I could draw, and the line of best fit would probably be something like that, right? It's a pretty strong correlation. Here you got a few of these things that are kind of off of that line, but not by much, and there aren't very many of those. Okay, so I could, I could find the equation for this line here. Notice that the way that I've drawn it, which may not be the best way to go, has it going through this point right here, which is the point 74, 200. Remember, this right here is my final exam score. That's what I'm trying to predict. So that's my Y, and my third exam is the X. But notice it also goes pretty close to this point right there, which is 68, 150. And so the slope of this line that I just drew is going to be, let's see now, rise over run. It's change in Y over change in X. This is from algebra. So that would be 200 minus 150 over 74 minus 68. And so we get 50 on top and 50 on top and 6 on the bottom. And so that's approximately 8 1/3. And so that is my slope. So that's, what is that? Is that A or B in this book? B. So that is B. A, if I wanted to find A, I would have to solve using one of these points. So I'm going to go ahead and put 200 equals A, which I don't know, plus B, which is 8.33, and multiply that by my X, which is 74. And so A is going to equal 200 minus 833, 74. And so I would just need to compute that, which, since, you know what, I'm in Excel, I can do right now. So I'm going to go, this is my A equals, I have cap lock on, A equals 200 minus 8.33 times 74 gives me, oh, I forgot to do the equal sign. There we go. That's how Excel knows I'm good doing math. There we go. Negative 416. And you're thinking, well, that's absurd. You can't have a final exam score of that much. Well, that is why. So the model is not accurate close to 0, with X close to 0. So there's only this range that X is accurate. And so this value here is still very useful. And so let's go ahead and there's my regression line. And so I'm going to put in my y hat now. So this is going to be y hat, and my and this is just my predicted, right? This is my guess. Y hat, I'm going to put this as a by I. Okay, so let's put in B. B equals, we already did this. This is 50 divided by 60. Again, that's just the computation I get when I do it by I. So there it is. And so now I get equals A plus B times my X value. Okay, now I want to autofill this, so I need to put some dollar signs in. Put a dollar sign, freezing my A reference, the dollar sign freezing my B reference, and I want the other one to remain unfrozen. And I'm going to drag that down, and there's my by I predictions. Now that should line up to the purple line that I drew. So let me go like that. Oh, the let's see. The oh yeah, not bad at all. There we go. Yeah, so there's my by I prediction. Now that is not the true regression line, right? That's just something I did by I using those points. Now, if I wanted to find the true regression line, I'm going to need a few things. Let's go true regression line. Over here, what was this? This was by I. Okay, so with the true regression line, I need a few things. Well, I need R, my correlation coefficient. I need SY, and I need SX. Okay, well, R is very easy. I just use CORL, right? I use the actual CORL function. I put in my X data set, comma, I put in my Y data set, and this thing is going to compute what's called that Pearson correlation coefficient. And there it is, 0.66, pretty strong. And then I need my standard deviation. So I go equals STDev of this is the y's. And now I need equals STDev. Here are my x's. Standard deviation of the x set. Enter. All right. Okay, now let's put these together. So b, which is the slope, is going to equal r times rise over run. Okay, the y goes on top, x goes on the bottom. Enter. 4.82. Okay, well, that's significantly different from my by I estimate. And now let's find A. But before I find A, I'm actually going to need my y bar and my x bar. So let me go ahead and put those in as well. Put those in over here. So this is y bar. This here is going to be x bar. Equals average right here equals average. Get my average x's. There we go. Okay, now we're ready for A. A is going to equal y bar minus b times x bar. -1 for -173. Okay, so now let's go ahead and put in this other line of best fit. Let's see. I think what I'll do is I'll copy all of this. Paste it right there. And this will be my regression line, not by I. This will be the actual true least squares. Usually this is referred to as ordinary least squares line. And so I'm going to make my scatter plot again. Insert, charts, scatter. There it is. And then I'm going to add my ordinary least squares. And there's that plot. Okay, let's go ahead and look at these side by side. Oh, that's the same thing because look where it references. References over there. I don't want it to reference over there. I want it to reference over here. So I'm going to go, so that's my A. My A, I want it to reference that. Put in a $sign. My B, I want it to reference that one. Put in my $sign. And A30, that's looking at the right place. Okay, so that's good. So I'm going to go like that. I'm going to autofill that formula down. I'm going to check. Is that referencing the right A and B? Yes, it is. Okay, now my plot has already updated it. Let's take a look at what differences are. All right, well, yeah, I think this is a better line of best fit. Well, in that it does a better job respecting this point right here. So notice this point. So when I drew my line of best fit, I think I maybe kind of cheated a little. I don't know. I think in my mind, I sort of ignored this point right here. But the regression line here can't ignore it. It takes every point into consideration. So this point right here might have been a fairly influential point because it was so far off the normal line. But yeah, so this right here, then, this is my true best fit regression line of the data. notice it underestimated this point right here, whereas my line overestimated it. See, my line, the estimates were the orange line, were the orange points. Those are my estimates. It's the same story here. Orange is the estimate. That's our second column. And yeah, so this one underestimated it. It estimated it to be, 280 maybe. I estimated this to be 210. Okay, well, I think that's all I wanted to demonstrate with this example. So, all right, and so to wrap up, let's go ahead and just take a screenshot of this for our notes, right? There we go. So we did it by eye, and we did it using the regression formula, and we put all of that in, and you can go back and find where I did those formulas. Okay, so let's paste. Make this a little bigger so we can see it. So we talked about a scatter plot, we talked about computing the line of best fit, and we did it in two ways. One way, which you really won't do very often, that's the by eye, and the other way, which is way better, is using correlation, or using the correlation coefficient